Hello, my name is Rohan Patel, and this is my Physics Lab 1 on constant velocity. As an introduction, I observed, or the purpose of this lab was to observe the motion of some object that is moving at a constant speed with no change in direction. I used the tracker application to use a video and turn it into actual values that I could put on a chart. Some background on Newton's second law, as this is the principle at play here. So net force equals mass times acceleration. This is also written as the derivative of momentum over the derivative of time, or delta P over delta T, change in momentum over change in time. This is the original video that I had recorded. As you can see, the system in this video is the ball, and the surroundings are the Earth. So how was Newton's second law used? So since velocity is constant, there is no acceleration present. This means there is no net force acting on the ball. The expected results of this lab were an analysis of the ball video itself that gave me adequate values, as well as a computational model that correlates somewhat to the positions of the experimental video. So after analyzing the video in Tracker, some values came. So my starting position was set to the origin 0, 0, 0. The final position was negative 0.83200, and this is meters. So which means the displacement was negative 0.832 meters over a span of 1.633 seconds. Using these, I calculated the velocity, which came out to be negative 0.509 meters per second. So these are the table and the values of the position for the tracker app. And as you can see, the position ended around 1.633, or at negative 0.836 at a time of 1.633 seconds. These are the code table values. And as you can see, I came up with very similar numbers, maybe off in terms of the meters slash centimeters. And these are the tables from the code, uh, fairly straight, fairly constant slopes. This is the code itself, and this is the chart comparison. There is a disparity in the position or in the velocity graph of the tracker app itself, as I had to manually graph the points, and that could have skewed the data a bit since human error is present. But as for the position versus time graph, they are fairly similar in the sense that they have very similar slopes. So what ifs? Why I chose the orientation I did and set my origin to be the starting point because it would make finding displacement a lot easier and allow for me to more efficiently calculate the velocity and track the ball. If I had chosen to go to the right instead of to the left, uh, my x values definitely would have been positive. That's given. Um, yeah. So what does this mean? So the position graphs were nearly identical, and as I stated before, the disparity between the velocity graphs can be attributed to manually entering in tracking points, which could have skewed the data due to human error.